In this video, we'll go over motion graphs. These are graphs of position, velocity, and acceleration versus time. You will learn how to derive one of the graphs from the other one. In only 5 to 8 minutes, we will learn about all the types of graphs that exist there and how to get one graph from the other graph. So keep on watching as we start by examining the fundamental relationship between these three variables. So to get the velocity from the position graph, we must look at the slope of this graph. Now, you might ask me, why is that the case? And let's answer this question by analyzing a really simple graph of position versus time. So let's say you walk 10 meters in 2 seconds. First of all, what is the slope of this line? The slope of this line is simply 10 meters divided by 2 seconds, right? So rise 10 meters over run 2 seconds, which is 5 meters per second. Now I want you to think, which quantity has the units of meters per second? Of course, it's velocity. So as you see, when we looked at the slope of the position graph, what we got was velocity. So therefore, to get the velocity from the position graph, you must look at the slope. Similarly, we can analyze a velocity versus time graph to prove that in order to get the acceleration from velocity, we must also look at the slope. Let's imagine a graph where a person is walking at a constant speed of 5 meters per second for, let's say, 2 seconds. So constant speed means that your acceleration is 0. And also, if we look at the slope of this line, right, it's a horizontal slope, so therefore the slope is 0. So once again, we prove that the slope of this line gives us the acceleration. So that's why the slope of the velocity will give us the acceleration. Another interesting feature of this graph is that if you look at the area of this graph right here, right, so let's analyze the area. This is a rectangle with a side of 5 and 2. So if I multiply 5 meters per second times 2 seconds, let's carefully analyze the units. The seconds and seconds will cancel out. So we have 10 meters. Meters are the units of what? Meters are the units of the position. So by looking at the area of the velocity graph, I found the position. So to go from velocity to position, I can look at the area. Similarly, you can imagine that to go from acceleration to velocity, I can also look at the area. So this right here is the fundamental relationship between these three variables. And if you understand this, the rest of this unit should be pretty easy. Let's start by analyzing the simplest of the graphs with the non-accelerated motion. Non-accelerated motion means that acceleration is 0, right? Or your velocity is constant, in other words. So as you see, there's 3 different regions on this graph. This first one, the second one, and the third one. And we will analyze them separately. So to go from position to velocity, we will look at the slope. So let's analyze the slope of this line. The slope is constant because it's a line. So its slope doesn't change. M is 0. Sorry, M is constant. And the slope is positive. So therefore, let's draw, again, by saying the slope, we mean the same thing as the velocity in this constant. So let's draw a positive constant line over here. Now let's take a look at the second interval. So here, the slope is constant and it's not changing, right? So basically, change in y is 0. So once again, it's a horizontal line, and a horizontal line has a slope of 0. So the velocity here is 0 as well. Conceptually, you can understand this as its position doesn't change, right? So it's stationary at this interval. Now let's take a look at our final interval where the slope is constant, because again, it's a line, but it's a negative slope. So therefore, it means it's a straight negative line right here. So look at this once again. If your position graph is one of these lines or consists of one of these lines, your velocity graph is always going to be a straight horizontal line above x-axis, on the x-axis, or below x-axis. And your acceleration, the slopes of all of these lines is equal to 0, right? So therefore your acceleration is 0. Again, because the slope of every horizontal line is 0, which confirms what we initially said about this types of motion, right? This type of motion, we said acceleration is 0, so that's what we have in the graphical form. Now that we looked at this example, let's take a look at the example of accelerated motion. So in the accelerated motion, we will basically either have an upward parabola or a downward parabola. Just like with the previous example, we will break it down into two. So this case, our velocity is positive, right? Because this line is going up, so I'm approximating with a line. So a positive slope means that my velocity is positive as well. And over here, my slope is 0. Therefore, my velocity is 0 as well. And as we see, the slope decreases as we go from this positive value to 0. So I will just connect this and we'll see that the velocity, just like the slope, decreases. Over here, the slope becomes more and more negative. So as we see here, the slope is negative, so the velocity is negative as well. So we can draw this pattern. Again, in the second interval, the slope is 0, so my velocity is 0. And here the slope is negative, so the velocity is negative as well. And then I just connect these 2 points together. Very similar is the pattern on the right. It's just that here we start with a negative slope. And here we at a 0 slope. And once again, we go to a positive slope right here. Guys, it doesn't matter what the value of the actual function is, right? It doesn't matter that this function is above or below the x-axis. If I drew this parabola like this pattern would stay exactly the same because we're looking at the slope and not the actual value of the function. Just as a side note. Okay, from these velocity graphs, let's get the acceleration graphs. This is just a line with a constant slope. So it's going to be a horizontal line, but a horizontal negative line because it's a negative slope over here. And this is going to have a positive slope over here and a constant slope because it's a constant line. So these graphs on these 2 pages represent everything that you will see essentially in this unit, because any type of graph that you will see on your quizzes or tests are just going to be combinations, right, of these different lines. So I can draw like a combination of these straight lines and parts of these parabolas. So you just have to make sure that you can identify and break this down, whatever problem you have on a quiz or a test, into these little pieces. But let's practice first together from doing that. So here's our practice problems. This would be a good time to stop the video and attempt these on your own. But if not, just keep watching and we'll do these together. So looking at the first graph right here, notice there's two different regions, right? This one with a positive slope, with a positive constant slope. So the velocity is just a horizontal line above the x-axis. Again, the slope is positive and it's constant, meaning velocity is positive and constant. And over here, the slope is 0, so the velocity is 0 as well. Great. Therefore, acceleration is 0 as well, right? Because the slope of these lines is horizontal. Now, let's take a look at the second example over here. So once again, we have two regions that are basically just pieced together from the parabolas we saw on the previous page. Let's analyze them separately. In this first piece here, the slope is positive. Oh, sorry, the slope is 0. Therefore, my velocity is 0. And over here, the slope is negative. Therefore, my velocity is negative right here as well. So velocity will be decreasing. Then my velocity keeps going to the value of 0. So over here, the slope is 0. So it goes until here. And finally, let's look at the third example. So once again, I'll break it down into two intervals. Here, the slope starts at 0 and it goes to a positive value. So I will start my velocity at 0 and I will end my velocity at a positive value over here. And the second part of this is a line, right? So this is a combination of a line and parabola. And they don't necessarily have to connect. Like, I mean, this part with like a part that I'm drawing here. So here the slope is constant and positive. So therefore my velocity could be something like this, right? So when I said they don't have to connect, I meant that it's okay that they're disconnected here because the slope is also undefined here. Okay, now let's get the acceleration graphs of these. On this part of the graph, the acceleration, the slope is negative of the velocity. So the slope is negative over here. And here the slope is positive. Therefore, acceleration will be positive value over here. On this part here, the slope is positive. And here the slope is 0. So just like these, we looked at all of the examples of acceleration plots. But before we finish this video, let's quickly go over something called dot plots. You might not see it in your class, and if you don't, you can skip this part. But dot plots are just a different way to represent motion. So it's basically a one-dimensional representation of a position of particle at a unit of time, but at every unit of time. So for example, you put a dot every second. Let's analyze three different types of motion: accelerated motion, constant motion, and decelerating motion. In an accelerated motion, every second you cover, so this would be an example of position. In accelerated motion, every second you cover bigger and a larger position. So your dots are becoming further and further apart from each other. In a constant motion, if you were to make a dot plot, every second, right, because your velocity doesn't change, so every second you cover the same distance. So your dots would be equidistant from each other. And finally, in decelerating motion, if you started, let's say at a big velocity, let's say 10 meters per second, and then your velocity decreases, so every second you cover smaller and smaller distance like this. So dots are becoming closer and closer to each other. So just like this, we looked at all the conceptual example of motion graphs. In the next video, we'll go over quantitative examples. So how to actually calculate the slopes and areas and how to answer quantitative questions on these graphs. Guys, keep practicing and keep working on your way to an A.